Students, let me discuss about electric field. Okay, so we have some knowledge about field because we have discussed already field about gravitation, classical mechanics, and you also have studied these things in your 10th student. So what is field? Field is a region of space actually, and I have discussed about field in vector calculus also. First of all, calculus I have discussed about scalar field and vector field. Electric field obviously a vector. And what is field? Field is a region of space. Okay. So where there is some source element and that source element will do some effect on that region. And here the source element is obviously the electric charge, and charge will be at rest. Okay. So rest charge, every rest charge will do some effect or will experience, will give some force on another charge. Okay. So every charge particle, any charge particle at rest will make a region or modify the region around that charge, so that other charge will be, if any other charge will become on that region, then that charge will experience a force due to the previous one. So that region of space where the static charge can show some effects, some electrical effects in region of space, that region of space is known as electric field. So let me take a charge, source charge. Let me talk about a source charge like QS. So this is a source charge QS. This QS is actually source charge, known as source charge. Okay. So around this QS, there is a region of space. There is a region of space where this QS charge will show some electrical effects. Okay, show some electrical effects. So if other charge known as test charge is placed in this region, then this Q0 will experience a force due to QS. And here in this region of space created by this charge QS is known as electric field, or this charge QS or source charge. And here this Q0 charge is known as test charge. It is known as test charge, or sometimes it is known as observed charge also. Test charge or observed charge. So this is the region, electric field, the region of space. Now we are interested about the field strength. So what will be the field strength due to this charge QS? That is an important thing, because whenever there is a field, we will be interested about the strength of this field. And to know the strength of the fields, we have defined the physical quantity, electric field or electric field strength. So in general, electric field a region of space, but the strength of this region of space, in that region of space, the strength of the field created by QS is known as electric field strength or simply electric field. So let me define the physical quantity involving the electric field, which is known as electric field strength. Is known as electric field strength, or sometimes simply we can write here as electric field. So what is this electric field strength or electric field? This is actually the definition. You can say that the force acting by the source charge on per unit test charge. And this test charge is actually vanishingly small. That is Q0 tends to 0 always. Why it is vanishingly small? Because if this is not vanishingly small, this is large, then it will give a force on this charge QS, so that the electric field of QS will be disturbed. So we have to choose QH in such Q0 in such a way that it can't disturb the charge QS. Okay, so that we can measure the actual field strength due to QS on the charge Q0. So what will be the definition? Definition is the force acting by the source charge on per unit test charge. That means the electric field that is defined as denoted as E is equal to F divided by Q0. If F is the force on charge Q0, the force per unit charge is F by Q0, and that is in the limiting condition. Limit Q0 tends to 0. This is the condition. So the electric field E vector, if you talk about, it will be F vector by Q0. Or simply you can write that E is equal to F by Q0. So F is equal to Q0. Sometimes we will use this result. And mathematically the region, the electric field region will be extended up to infinity. But in actual case, in realistic situation, we can see that the strength of this field will be decreases and will be 0 after certain distance, or you can say it's negligible, not 0, but it's negligible. But mathematically, it will be extended up to infinity. Okay. Now, the electric field strength, that is E. This electric field strength E will, the magnitude of the electric field strength E will depend on this charge, on this source charge, the nature of this source. Because the Q0 charge, the test charge is fixed and that is very small and intentionally small. It should be. But what will be different in different cases, QS will be different. So sometimes this QS may be a point charge, QS may be extended charge, QS may be in the form of a ring. Okay, QS may be in the form of disk, QS may be distributed through a sphere, the surface of a sphere, throughout the volume of a sphere. So due to the geometrical shape where the QS is distributed, the electric field in this region of space will be different. The mathematical expression of the electric field will be different. But the main definition will be E is equal to F by Q0. So first what we have to do, we have to first find out the force on charge Q0 due to QS, whatever be the QS. Okay. So let me first discuss the very simple case, that is when QS is point charge. It is a very simple case. Okay. So let me discuss about the electric field due to point charge. Okay. So let me take this QS is point charge here, and we have to suppose find out the electric field strength at distance r from this QS charge. That is the point P here. So what we have to do, we have to place a test charge Q0 over here, and we have to find out the force on Q0. So force on Q0 will be 1 upon 4 pi epsilon naught into US into Q0 divided by r square. And if you talk about a vector, then it will be r cap, because the force will be along this direction. So this is the force. So what will be the electric field strength E? So E vector will be now F by Q0. Okay. So it will be just, if you divide this equation by Q0, it will be just 1 by 4 pi epsilon naught US divided by r square. So this is now the expression of the electric field per point charge. It is 1 upon 4 pi epsilon naught US upon r square. And you can find the magnitude E is proportional to 1 upon r square. You can see from here, electric field will be 0 when r tends to infinity. So the electric field strength mathematically can be extended up to infinity, but in real situation, it will be negligible after very far away from this charge QS. And you can plot this E proportional to r square. If you want, you can plot it along this direction is E and along this direction is r. Just like rectangular hyperbola, but it will vary more rapidly than the rectangular hyperbola. So in that case, it will be E proportional to 1 by r. But here it will decrease rapidly to the, then E proportional to 1 by r. 1 by r square will decrease rapidly. So this is the E versus r graph. At r is equal to 0, it will be infinity, and r tends to infinity, it will be 0. Okay, so it will be extended, can be extended asymptotically. Okay, along E axis and r axis. So this is the graph between E. Okay, now you can express this This result in different way also. If you want to express it in instead of r cap, if you want to express it in terms of r vector, then you can put r cap equal to r vector divided by mod. It will be in that case 1 upon 4 pi epsilon naught into qs upon r square into r vector divided by r. Okay, so it will be 1 upon 4 pi epsilon naught qs upon r cube into r. This will be okay. But in terms of position vector, we can represent this expression. We can write this expression in terms of position vector also, because here the position vector of q0 with respect to qs is r. Here the position vector is r. The position vector of q0 is r with respect to qs. So qs is taken at origin. But if you choose an arbitrary origin, then what will be the expression? Let me show you. To take an arbitrary origin, suppose this is qs and here is q0. This is the field point p. So if you take an arbitrary origin like this, and y and z also there. So this will be the position vector of this charge qs. This will be the position vector of charge q0. What will the position vector of this? This is the field point p. Let me take this as rp and let me this is rq and this is rp. So the position vector of p with respect to q. This point let me take as q. The position vector of p with respect to q, according to triangle law, it will be just rq plus qp equal to r. qp will be rp minus p minus r. In this situation, you can express e vector 1 upon 4 pi epsilon naught will be q by r cube. So qs by r cube means here this vector, and this vector is rp minus r cube. It will be mod rp minus mod r cube whole cube into r vector means rp. You can express the electric field density in terms of position vector. Okay, and sometimes you can solve numericals in terms by using this equation, because this equation will give you the magnitude of E as well as the direction. Okay, so let me solve one example so that you can understand. This is the example. So a charge q is equal to 1 microcoulomb is placed at a point 1 meter, 2 meter, 4 meter. So suppose this is a point, okay, 1 microcoulomb charge is present and the point is 1, 2, 4. So this is actually q point according to us. This q point, and the position vector of p point is given as 0, minus 4, 3. Okay, so we have to find out this rp minus rq vector. Okay, so what will be rp minus rq? Rp minus rq will be 0 minus 1 I cap, 0 minus x2 minus x1 I cap, y2 minus y1, that is plus minus 4 minus 2 okay, z2 minus z1, that means 3 minus 4, 3 minus 4 okay. So it will be just minus I cap minus 6 j cap minus 6. So this will be rp minus rq. And what will be the mod rp minus rq? So mod rp minus rq equal to root of 1 square plus 6 square plus 1 square, that is root 38. Root 38. Now if you want to express E vector in this way, 1 upon 4 pi epsilon naught u upon rp minus rq mod whole cube into rp minus rq. Okay, so this will be right. Now it will be 9 into 10 to the power 9. Q is 10 to the power minus 6 coulomb divided by 38 to the power 3 by 2, and this RP minus R2 you can write minus IK 0. Okay, this will. So this is how you can solve the problems in terms of position method. Okay. So now in the next class I will solve problems based on superposition principle. Which means more than one charges are given, then superposition principle we have to use. And before that I will discuss also superposition. So I have discussed superposition principle for Coulomb's law for electric force, but I will again discuss about the superposition principle for the electric charge in more detail. Okay. Then I will solve some problems on electric field and continuous charge distribution also. Okay. This topic will be completed.